Hospital porters, pride and dignity. Stop the New World Order! Are there any hospital porters here? You're ex-hospital porters?
No, not at all, mate.
I'm at the wrong meeting. I'm in the wrong place. I'm at that critical mass thing, aren't I? It's lucky because the X-ray porters who were after me haven't turned up either. They're sort of like they're somewhere on the M26, I think. X-ray porters being X-ray porters. Before we begin, for viewers on the Panmo TV, I just want to sort of like strategically place that in front of you. That's the Critical Mass Orator newspaper. Please get a copy. All kinds of articles on there. So check that out. It's a really, really good newspaper. Accompaniment to the radio station. Now, as I explained, I'm not a hospital porter anymore. I was for 23 years. It's how I came to be an ex-hospital porter is a story I had told before, and I told it in detail at the last conference. Suffice to say, the situation where people are being persecuted through the workplace for having interests like ourselves is continuing. Since I have had this experience, I've been approached by other people. Some of them have gone public and they've spoken out. Tony Farrell is a very well-known example. Kevin Annett, of course, in Canada. I've been approached by several other people who want to remain anonymous, but one of them, I mentioned her at the last conference, I think. She's a lady from Scotland who organised a truth event up there, a conference. She works in the public leisure industry, and she has been sacked. And only 2 days ago, I was contacted by another person. This is a quite well-known YouTube personality who does conspiratorial videos. This person has lost their job too. So how much longer can the cries of coincidence go on? There is a secret policy in place that is persecuting us through our workplace. I mean, statistically, if it's just seeing you guys and us are more likely to get into trouble at our work than anyone else, regardless of whether we're outspoken or not in the workplace. And even if we are, so what? Why shouldn't we be? We're supposed to have free speech in this country, but we don't. There's a secret policy in place that denies that. Sometimes it's not so secret. But in this case, it's subliminal. It seems to be almost like a subliminal programming of us. Those of us who lose our jobs, it's almost a hidden warning, a subconscious warning to the rest of us to keep our mouths shut and to not talk about these subjects and not think about these subjects. But anyway, today I'm going to discuss a different topic. It's actually 2 separate topics, and you may think it's a strange lumping them together because they're very different in many ways. Energy politics and UFOs. They're treated very differently by the media, you might have noticed. You have energy politics is in every news programme. You switch on the news and they have a scene where they talk about oil prices, and someone in a suit with a very, very serious expression talks about, the latest shareholder takeover of various gas companies and electric companies and things like that. UFO stories in the mainstream media, what they like, they're always at the end when they want to have a laugh about something. You get some guy, a reporter, with a sort of mock serious expression on his face going, where we had a UFO sighting, there was a UFO sighting at this event and at this place, and many people come forward to see, they've seen strange things. And while he's talking, somebody above the camera, the field of view, will dangle a toy alien or a model flying saucer around into the field of view around the reporter's head, and the reporter will go, "What's this?" Oh. And everyone in the studio will go, and then suddenly it's riotous all round. That's a UFO story. So how do these 2 possibly fit together? Well, if you get all your information from BBC and ITN, they don't. If you come to this conference and listen to Critical Mass Radio, you'll find they do very well indeed. But first of all, what actually is energy, first of all? Energy is quite hard to define. You can even ask someone like Stephen Hawking, he'll say, "I don't know," he'll be he won't be able to answer your question completely. It is an indirectly observed quantity in the universe. That's what it is. It's part of the workings of the universe. Part of the laws of physics is energy. And it's best defined as something, anything that creates change, motion, and has the ability to do things like to cause any kind of transformation in any physical state. For instance, if I lift my arm up like that takes energy, right? The energy that is, the energy comes from the food I eat, mixed with the air I breathe in, with the oxygen and gas in the air I breathe in, which causes a chemical reaction called combustion, which generates energy. And so every time you move, every time you do anything, every time anything changes or happens in the universe, it's a result of energy. Energy that is intrinsic in whatever's doing the changing and transforming. Now, as far as our world goes, our human world, our civilization, energy is always a vital part of it in terms of its politics, culture, economics, everything. And the main source of energy in our civilization is oil. Black gold, it's the lifeblood of civilization, it's the lubricant, it's the fuel of civilization. There's very, very little energy that is actually goes on in our world. Mechanical energy, not biological energy, mechanical energy or electrical energy that doesn't come from oil or from a fossil fuel like coal. And that is something that is surprisingly recent in history that it's come to this, because really, official human history goes back like about 5,000 years to the early ancient Egyptians, the Sumerians, and for almost all that time, apart from the last few hundred, it was basically manpower or beasts of burden like horses, donkeys, and camels. That was it. All energy came from that. You did something yourself with your own muscle power, or you've got some animal to do it for you, a trained animal who could do it for you. Richard Heinberg is a very, very interesting guy. I disagree with a hell of a lot of what he says, but he does understand the principles of what he's talking about. He explains how human society has progressed from this basic state of basically you did, like say, muscle power, you drag things, you pick things, you carry things yourself, get a trained animal to do it, and that was basically how it was for a good few thousand years until basically the last few hundred. He explains how how the pyramids were built basically this way. Wow, that's a big subject, all right. I mean, I know there's a lot of evidence to say that the pyramids were actually not built in that way, and Heinberg and all the other official historians are wrong in that department. That's a big subject. We're going to touch on it a little bit later, but just imagine for one moment there was no evidence at all that the pyramids were anything other than stone monuments constructed by hand. Basically, they used people to pull these lumps of stone and arrange them. And then suddenly, boom, just 200 years ago or so, the Industrial Revolution happened and kicked off. It started right here in this country, especially in cities like this one, Liverpool, and right across the North Country, London, spread to the rest of the world. And what really caused the Industrial Revolution was the use of fossil fuels. In the first half, the first century, it was coal. In the second half, it was oil, fossil fuels. Now, again, we're going to I'm going to have to skip round another issue, which may well be true, and I think probably is true, but for the sake of convenience, I'm going to have to just pretend it's not true, and that is the question mark over whether these are fossil fuels. I mean, Ian R. Crane talks a lot about this. He's here today, actually. He's sleeping off his hangover in his camper van outside. He's going to come in later and buy us a beer. So I'll go and wake Ian up later. Anyway, he talks a lot about how oil might actually be abiotic. In other words, it's not caused by the breakdown of ancient life forms, things like that. Actually, there's evidence for this, like oil wells sometimes replenish themselves, after a few years and things like that. But of course, the oil companies keep it quiet because if it came out, oil could reproduce itself, price would go through the floor. They don't want that, And there's also the reason that there'd be less for us to be scared of. And that's another big reason I'm going to come to later on. This is very important. But basically, we went from having just man-animal power, muscle power alone, by using biological energy to do mechanical work, to a fuel source that was hundreds and thousands of fold more efficient. For instance, in your car, your petrol tank, right? Your car's petrol tank, the petrol in that tank has the equivalent energy of 250 Roman galley oarsmen. Believe it or not, that's true. Right? Every time you turn your car, you turn the key in the engine ignition on your car, you have 250 Ben-Hurs under the bonnet, you know, going, I'm not kidding, you know, a car has the same energy it has, it's incredible. Now, if you want to know what life is like, Heinberg puts this very well, he does a very good demonstration. If you want to know what life would be like without that oil, and I'm going back to biological power again, get out of your car, and don't put petrol in it, get out of your car and push it, see how far you can get with it. See, that's a good illustration. Now, our entire human world is constructed on that foundation of this energy source. You know, it's the biggest industry. Well, it's not just the biggest industry. It is industry. It is business. You take it away, everything else is taken away. All our cars, lorries, railways, aircraft, all run off oil. As I said, like 100 years ago, these machines that were run off oil were run by coal. For instance, a good example is railways. Of course, a century ago, even in fact, railways continued to use coal right into the oil age, until quite reasonably recently, when petrol cars were on the road, railways were still running off coal. There's like the old steam train chuffing around. Ships, until about 100 years ago, ships' engines run off coal, change to oil. Electricity as well. I mean, everything from running that light to sending a rocket into space requires energy of some kind. Chemical energy, combustive energy, transformed into mechanical power. Let's just arrange these. Somebody very nicely offered to give me small pieces of paper. This is the fifth time I've done a live speech, right? So bear with me. I mean, I think as long as you can count the number of speeches you've done, you're still a beginner. So I'm sort of like, when I can start, no one can count them, I'll be sort of like, I'll be okay then. I won't have any problems with that. That'll make a noise. Now, electricity comes from power station. It comes from the national grid, and which is run in pretty much the same way in any country. What you have is you have your power station, you have wires, everything's run off wires, but the electricity used to generate the power that runs that light is not generated in that light. It comes from a long way away. In fact, it comes from the national grid, which is spread out over the whole country. As I was coming up here on the train, when I just passed Runcorn, there's a big power station there, which is pretty similar to many others. There's a big one near Didcot, and they're not very nice. They're eyesores. There's nose sores as well because they smell really badly. There's a town in Oxfordshire called Didcot, which has got a huge power station in, and it has very little else in it actually, and it's really is horrible little place. It really is. Now, what they is these power stations are connected to wires, which are laid over the entire country, like gossamer lines, all over the country, in the form of pylons, which stretch out from Land's End to John O'Groats. These pylons connect to substations, which connect to electric mains, which connect to our homes and businesses, and this building here, to allow us to have these lights. The national grid is charged at various places by these power stations. Now, a power station like the one I saw at Runcorn, I think it's coal-fired. Didcot power station is coal-fired, and I think most of them are. The coal-fired, it's actually very simple. What happens is, there's a furnace which burns coal. Not British coal, no, British coal is a luxury item now. No, Margaret Thatcher closed down all the coal mines, so we have to import our coal. We get cheap coal from abroad, from Russia, where it's ground down into powder and fed into a furnace. And it burns and it heats a boiler of water. The water then turns to steam, it runs through turbines, which spin a dynamo, and the dynamo charges the national grid. The water then goes into cooling towers, which all pie-shaped chimneys, where cold air comes in at the bottom, condenses the water, and it turns the steam, it turns back into water, and the water is pumped back to the boiler, and the process starts again. The disadvantages of that are, it's, as I was saying, it's very unpleasant. It doesn't only smell bad, but the toxic chemicals released are actually very bad for the environment and they're bad for our health. And they are from an apparently unsustainable source, like coal. You know, that this coal is getting more and more difficult to get hold of. And it's getting more expensive. Even though they're using cheap coal now, where the mines don't have the same safety procedures that British mines used to have. And more and more miners get killed in Russia than get killed in Britain. It's still getting more and more expensive. Now, again, you've got to ask yourself, there's a question of whether that is a real scenario or whether it's engineered. And of course, if you watch Ian R. Crane and his views about the oil industry and fossil fuels, you may well see it differently. But whether it's engineered or not, that's the situation we're in at the moment, where this source of energy is not going to last us forever. It's just where it doesn't, because like I say, it's releasing toxic chemicals into the atmosphere, into the ground. I'm not going to mention the C word. I'll write it down though. It is a trademark. It has been recently rebranded. It used to be called carbon dioxide gas, and now it's called carbon. So don't get it wrong. You'll get sued. As I said, you know, again, apparently this is highly dangerous. This gas. I'm not convinced by that at all. I'm very doubtful of that. I think a lot of people in this room will be as well. As I said, in terms of oil, it's exactly the same. Again, we don't know whether this is an engineered situation or whether it's real. I suspect the former. That oil is getting harder to find. The price of oil is getting higher. This is why they've got all these deep drilling oil rigs now out at sea, like the one that blew up in the Gulf of Mexico in 2010. These rising prices are causing economic problems, or apparently causing economic problems, because the price of oil affects the price of everything. This is the thing, the energy we use, all the energy we use has to be paid for. We have to pay for it. Every electricity user in the world gets an electricity bill. You get sent through the post. I get one, you get one, we all get one. We have to pay it. It costs money to drill for oil, to mine coal. It costs money to transport it. It costs money to run power stations, these big power stations. It costs money to run the national grid. It's an expensive, inefficient process. Millions of man hours every day. And half the people in the world just really can't afford it, or at least not much of it. And we call that the third world. Again, you've got to, you know, I'm not saying for certain that this is a genuine situation, it could be an engineered situation. Acres of countryside get ground up to build these power stations, they get ground up to build these substations. There's strong evidence to say that people who live near pylons and power lines are less healthy than those who live away from them. Childhood cancer rates, according to some studies, are said to be higher if you live closer to these power lines. And another thing about it is it's actually inefficient. I mean, we were saying before about efficiency. Now, muscle power is actually fairly efficient. The system we have now, although it's, perhaps when I said efficiency before, it was the wrong word. I should have said quantity, not efficiency. The system we have now is not efficiency. An awful lot of the power that comes to run that line from the national grid gets lost. It gets lost because the circuits are so huge because of resistance. All circuits have resistance to them, except there's the superconductors, which are very low temperature circuits. There's evidence that room temperature superconductivity has been discovered, but they're keeping very quiet about that. That's a big subject. But basically, probably a proportion is half or so of the power is lost due to circuit resistance, even though they use copper wires. Copper is the second most low resistance metal there is. Silver is the lowest resistance metal in terms of heat and electricity. Because if you have a silver teaspoon, for example, you can't, you have to have some kind of insulator on the handle, otherwise you burn your fingers when you stir the tea. The heat just shoots straight up the spoon into your hand. Silver, of course, is very expensive, so they use copper instead. But even so, there's this large circuits we have on the national grid, full of resistance. This is why a lot of if you know a lot of kind of sort of new age kind of like independent kind of people, a lot of them are keen on micro-generation of electricity. That is where you have your own generators and solar panels on your own house and things like that, which is a good idea. But I'm going to go into, when I go into more detail, you'll realise that even that, is a good idea, but it may not be necessary. Well, Heimberg, he's a very, as I said, I don't agree with a lot of what he says, because he has a rather doom and gloomish kind of view of the world. He draws a graph like this. Right. This is just the amount. That's just the amount of various things. This is time, and he measures it in so many centuries or whatever along there. And he basically draws a graph. He explains how he has this. This is the level, what he believes is the maximum level of population the Earth can sustain is there. And what he says is, for hundreds of years, we were tinkering on just fine, just a few 100 million people. Then the Industrial Revolution comes and we go like that. And suddenly there are billions of people on the Earth. This is what Heimberg says, not me. All right? And he says this happened at the same time, so that's population, that line. He says that happened at the same time that energy increased. So here's energy. Like I say, you've got muscle power only, man and animal power, and then suddenly Industrial Revolution shoots up and there's energy. Now, so you can obviously see there's a correlation. The energy we're using mixes population. Now, Rob says this was dry, but we'll see. I'll use something else if it's not. All right. But
I smoked it then.
that's all right. That'll be fun. Now, according to Heimberg, there's resources. There's resources like this. This is what he calls the resources of the Earth, which include things such as energy in terms of fuel. Also things such as farmland, water, fresh water, things like that. And he says these are finite things and they're going to go down like that. This is Heimberg's graph. I'll be drawing one in my own later, which is a bit different to this. Now what he says, when that point happens, right, energy then plummets like that. Energy goes like that. And come back. Population does the same. It follows suit. That looks pretty grim, doesn't it? Because, I mean, lots of people in the world, population, it suddenly plummets like that, means a lot of people are going to die because the resources are gone. And he said this all happens because we went over that maximum population and energy expenditure level. So, when that happens, there's all kinds of political problems. You get social unrest. You need maybe a one world government, perhaps, a database. Everyone very tightly controlled by electronic implants. Good idea, don't you think? Complete state and corporate control of all industries. No nation states, just a communist corporatocracy global government. Sounds familiar? Yeah. New World Order. And these will come out of the chaos. What this would cause, would there be chaos? Wars, civil unrest, strife, famine, as people fight over these remaining resources. That's Heimberg's graph. Looks pretty grim. So what can be done about that? Well, I mean, of course, quote the immortal words of David Icke, something must be done, this can't go on, what are they going to do about it? Well, that's basically what Heimberg is saying. He's talking about things such as, he says things like deindustrialisation, which is pretty much the same thing. I mean, he paints a rosy picture of it. But he talks about, you know, zero growth economies, things like that. But I wonder if secretly, at the back of his head, in mind, he's wondering whether that's too little too late in his model. And I know there are people like the Club of Rome, who are saying they're much more open about it, they're much more extreme, and they're much more desperate. And they're basically saying, asking people nicely to not use mobile, you know, not use so much energy, ain't going to work. And some of them, and not all of them, are out to build a new world order. Some of them, I think, are just people who genuinely buy into all this. They genuinely believe this model, and they genuinely believe there's no alternative. And those people are used by the ones at the top who know this is all over crap, for the reasons I'm going to explain in a moment. I mean, Heinberg talks about things such as wind and solar power, and he says it's not enough. It's not efficient enough. And he's right. I mean, wind and solar are the only alternatives really allowed. They're the only alternatives used, which the government allows to use, and they have very high overheads. They're very, very complex. They're very, very difficult. And they work on a small scale, but not on the big industrial scale. Although I know the Venus Project, people like that disagree. Nuclear fission. Now this is quite uncommon. I mean, there's a lot of nuclear power stations in Britain, across the world. Some countries have more of them. They are basically, they work exactly the same as the coal-fired stations, except instead of a furnace run by coal powder, they have a nuclear fission pile. Rods of heavy metals, uranium, which are brought together into what's called a critical mass, which is a familiar term to us all, isn't it? It means something very different, though. It means they reach the point when the nuclear reaction takes place and the atoms start splitting and crashing into each other, and the particles hit other atoms, nuclei, and they break off, and there's a chain reaction, and this is but it basically that generates a lot of heat. The fuel rods get very hot, like a kettle element. They boil water, and the water heats the water in the boiler. And if you want to know the disadvantages about that, just look at Fukushima, Chernobyl. Although again, there's evidence that Fukushima was more than it seems to be. Every time I often have to bring this up, I have to talk about things and then tell you they may be a load of crap anyway, but bear with me, you know. You have to suspend your disbelief, make assumptions for the time being. Now there's a lot of media coverage about this. I mean, I could go into nuclear fusion power, which is it's similar. What it is, it's similar in a sense because what happens is they get they use something called deuterium, which is actually very common. It's in water. Every one every million water molecules contains a deuterium atom, which is an atom, which is an isotope of hydrogen. Do you mind that you take a sip? And that actually can be used at very high temperatures. It can be fused together to create other substances, like tritium, I think it's called. And this releases an awful amount of heat. And there's a big research facility in Oxfordshire, just a few miles from where I live, where they're working on this. And there's a new one being built in France right now. And they're saying maybe it could take a number of years, a number of decades, but they hope to have a fusion power station. And it's all in this big sort of like tokamak-like thing, which is a big circular donut-shaped thing like that. And they're all these atoms. It's very hot in there. And it's very there's hardly anything in there. It's almost a vacuum. It gets very hot in there, and the heat comes out, and it can be used for energy. That's another thing they're doing now. That has a lot of practical engineering problems, all right. But there's billions being poured into it. Perhaps because it has these problems, it may well turn out to be a technological cul-de-sac, and that could be why the government is promoting it, not just in spite of that. Now you hear an awful lot in the media about this. You have, George Monbiot is very a big pundit over this matter, or as Alex Jones called him, Lord Monbiot. Lord Monbiot! Lord Monbiot! That spindly little twit! I don't agree with Alex Jones on everything, but he's got a point here. But you just get the distinct impression, really, that there's no real solution, and that really people like Heinberg and Monbiot are basically just paving the way for this to happen, and they're half-heartedly trying to pull us out of it. I think a lot of them are genuine, and they're not. Heinberg, I don't think is a bad guy. Same with Monbiot. Well, I think Heinberg's got more brains than Monbiot. But the thing about what's strange is if you look beneath the flannel, you won't get this from the mainstream media, only when they want to debunk it. There is a very simple solution to this problem, and that is the use of free energy. It's there, it always has been there. Free energy is it's the universe that's actually in the fabric of space itself, called zero-point energy. It actually exists even when, if you cool something down to absolute zero, there's no heat in it at all, there's no sort of thermal energy, no motion, no molecular motion, nothing. You still get this energy still there. If you can find a way to tap that energy, it's an enormous amount of it. Just a cubic centimetre of vacuum contains enough energy to run the world for 50 years. Some statistic like that, an awful lot anyway. It's clean. I mean, I'm going on to methods now. There are methods for tapping it, you see. Science says it's impossible, but official science, but there are methods for doing it. It always has, it's free, it is clean, and it's safe. And it is there in infinite amounts. There's no limit to it at all. You never have to worry about running out, ever. And it's even present in nature. I mean, there are animals that have evolved to use it, which I'll talk about in a moment, and plants too, I believe, if I'm correct. It can be observed in some kinds of weather, very common weather phenomena like thunderstorms and tornadoes and things like that. And there's actually the methods people use to extract zero-point energy. The people who have developed it are actually the methods are surprisingly simple. There's no massive complex piece of engineering or apparatus necessary. It's often very, very simple. So I mean, if you're unfamiliar with this subject, you're probably going, what? It's been discovered? Someone's finally discovered it? No, it was discovered long ago. I mean, it's hard to trace it back actually, because it was actually, if you want to trace back the documentation and the papers, they go back into before the age of oil. They go back to the first half of the Industrial Revolution, which was based on coal. Yeah, it's true. There were people in the 19th century who were developing this, who discovered this. There's a guy called John Keeley, Thomas Townsend Brown. I think he came later. There's a guy called George Pigott, who's in future ages it will make lots of school kids laugh when they finally get round to teaching this in schools, right? Because George Pigott used to levitate his balls. Yes, he did. All the kids will be laughing at that. I look forward to that day. He found a way to create an anti-gravity effect in steel spheres, and he actually patented his invention. Now, the most famous of these early pioneers was no doubt Nikola Tesla. It's a name I'm sure you've all heard. He was a genius in the field of electricity, electrical engineering and science. In fact, he was one of the pioneers of it, along with others. Excuse me. Along with Thomas Edison and others. He had a bit of rivalry with Edison over what kind of current we would use. Edison wanted direct current, which is like what you get from a battery. He wanted that on the mains. Tesla says, no, we need alternating current. Of course, we have it. We have alternating current. Tesla also understood, he was an extremely eccentric man. He hated human contact. He wouldn't shake hands with people hardly. He would go to social events and he'd be like this. He'd be worried about catching something from somebody. And he never got married or had a girlfriend. I think he had plenty of offers from ladies, but he just turned them down. Very, very unusual man. But like all of these great people, these great geniuses, there's a fine line between madness and brilliance. And Tesla tiptoed that line very, very well indeed. Now, he said that there was he discovered many things. He built several apparatus that tap into the electrical energy which exists in this planet. The power that is in the body of the Earth. The body is just not, it's not an inert ball of rock floating in space. It has, just like our bodies do in our nervous system, the Earth has its own form of nervous system, which is electrical. And there's enough power in it to run every electrical device in civilization 100 times over. Tesla also understood about the 0 point. He understood about 0 point energy. He's famous for building his big tower at Wardenclyffe-on-Sea, Long Island, and the Tesla coil and things like that. And he's immortalised by the alternating current, and of course, funnily enough, the magnetic power is measured by a unit called a Tesla. And I've thought about it because when I was at my hospital, they delivered a magnetic resonance imager, and they said, it's amazing. It's a 3T magnet. And I thought, what does T stand for? I asked this radiographer. This is a radiographer. She's like, I'm not sure. It actually stands for Tesla, but it's always short to T for some reason. The most powerful magnet ever made is 4T. There are other examples. There's people like Brewster Palmer, Thomas Townsend Brown, and today, very famously, who's a guy who's operating today, John Hutchison, who a lot of you will have heard of. Dr. Judy Wood his work was trying to develop a lot of the things that he came across. Another is Edward Leedskalnin, and that brings us into the pyramids. Now, Edward Leedskalnin was a guy who built something called Coral Castle in Florida, which is like a stone monument made out of blocks of coral, heavy hard stone. And you can go visit it today actually, get in there, it's very impressive. I've not been there myself, I know people who've been there, you can just go in and look around. He built it surprisingly, in secret, single-handedly. And people often wonder, well, how did he do that? Because I mean, there's no way anyone could move these lumps of rock, even with mechanical aid, if you need help. He did it single-handedly. And the mystery made out, he was apparently fascinated by the pyramids in ancient Egypt. And there's evidence to say that he actually discovered 0 point energy that might have been involved in the construction of the Egyptian pyramids. Another example is Victor Schauberger. Now, this is an interesting guy. He's less well known than Leedskalnin and the others. What's the time? Let's check the time. Cool. Victor Schauberger was a forester. He just worked in Austria, in the mountains and woods of Austria. In the 1920s, he was a forester, and he noticed something. This comes back to the processes of nature exploiting 0 point energy, and how life has evolved to exploit 0 point energy. You know, evolution has no qualms about this, the way governments do. I mean, he observed fish in the river trout, and he noticed that they seem to move effortlessly, even in strong current, without hardly ever moving their fins. And he worked out, how do they do that? He did a couple of experiments. He put hot water into the river upstream, and he let it rush downstream. Apparently, when this hot water hit fish, it warmed the river up a few degrees, and the fish suddenly went crazy. They started flapping their fins, and they lost control. When that hot water passed downstream, they regained it again, and everything returned to normal. So it's obviously connected with the temperature of the water, he found out. Now, and he worked out the temperature is very important in that sense. But he discovered actually that water itself has 0 point energy effects. And this even impinges on our lives sometimes. Have you ever switched, if you're in a house that has bad plumbing, you ever flush the toilet, or you switch on a tap and you suddenly hear a growling sound coming from under the floorboards? Has that ever happened to you? It's a water hammer effect. Now, sometimes, not always, I mean, I've not looked into this in depth, but apparently, sometimes this is caused by this 0 point energy effect of water coming out. Now, a big problem with all this is, right, is that, so it's not a problem, I don't think it's a problem, but it is a problem with society, that society has, is that the people who tend to get involved in this line of research are amateurs. They are what is derogatively known as tinkerers. John Hutchison has been called by the skeptic, the modern skeptics call him a tinkerer. All the others, Brewster Palmer, Keeley, Townsend Brown, George Pigott, all tinkerers. They're not proper scientists, not trained in science. They're just amateurs who are self-taught, and they decide to do it at this, in their spare time as a hobby. They build these machines. Now, a lot of these are Americans. You know, Stanley Mayer is another one, the guy who invented this famous water cell. Now, the United States actually has a great tradition in this. You know, people like the Wright brothers and Thomas Edison. These were like tinkerers who, you know, invented things in their garden shed. Thomas Edison invented the light the light bulb. Not these ones, these are new ones, but the old filament light bulb. He invented that in his garden shed in his evenings. The Wright brothers as well, they ran a bicycle shop, the bicycle repair shop. They went and built the world's first aeroplane. And these are people who tend to get involved in this, maybe because they are not hampered by the pressures of academic life and indoctrination. It's got to be said, indoctrination. I mean, what Schauberger ended up being forced to work for the Nazis when Hitler annexed Austria. Now, what happened to him after that is all a bit shady, but it looks like he was involved in some of these man-made flying saucers you hear all about, the hand-blue craft and things like that. It's a big subject, and but another example is this did come from some proper scientists. It was called cold fusion. You might have heard about that. It happened about 20 odd years ago. There was these guys, Stanley Pons and Martin Fleischmann. Martin Fleischmann died a few months ago, actually, and I did a little bit of tribute to him. They were doing a chemistry experiment. These guys they don't normally get involved in this sort of thing. They discovered this completely by accident. They were doing a chemistry experiment, which was really, really simple. Again, there's no large hadron collider required for this sort of thing. It's extremely simple. There was a test tube full of deuterium, and they put in these electrodes, and they ran the current through. Now, this is electrolysis. This is schoolboy science. If you went to school, you did this yourself in your science class. But what they were hoping to do was get a chemical reaction out of the substance in the test tube, which was deuterium. This fuel, this fusion fuel I told you about. What they got instead was an enormous amount of heat. And they said the only thing they could think of that it accounted for was nuclear fusion. And that hit the media. I don't know how many of you remember, you can get it all on YouTube, there was a media storm. And basically for a couple of weeks everyone went crazy over it. And then it just was shut down. It was just finished. And there seems to have been it's a big subject, there was a cover-up instituted over cold fusion. Now, it's a bit suspicious because one of the guys who was involved in that was someone called Stephen E. Jones. Now, he's one of the guys who's not very keen on John Hutchison and keeps slagging him off today. So Stephen E. Jones is a name that seems to be connected to these kind of activities. That's a big subject. That's what really surprised me when I started looking into this cold fusion business is, you know, Pons and Fleischmann weren't the first to discover it. It was discovered independently several times, and the first time was in 1926. So why? What's going on? I mean, there was a big fuss over it in BBC Horizon. Now that's a TV show that I always watch, and about one programme in 5 is good. The rest is all crap. It's all disinformation. They said that they knew that there was no fusion going on. They said they kept concentrating. It's not nuclear fusion because we haven't picked up the neutrons, because neutrons are emitted from deuterium during fusion, or tritium, whatever it's called. And they didn't pick this up. And by focusing on this issue alone, they forgot to ask the obvious question, well, where's this heat coming from then? And in a sense, it doesn't matter. Well, the point is, if this, we could have had this in 1926, we could have had this. It doesn't matter if it's not fusion. The heat has been generated. This is why today, when they're doing it today, they call it the anomalous heat effect. All it is once this heat comes out, it doesn't matter. You can rig it up to a boiler, you can boil water, you can run it through a turbine can spin a dynamo, you can get power. You can sort out the details later. The fact is, it works. Doesn't matter if you can't pick up neutrons from it. Doesn't matter if it's not proper fusion. We could have had this. Just imagine if the world had been different. If Tesla had been allowed to publish all his results and his work had been completely put into public use. Now, Nikola Tesla, some of his papers are still classified after more than 100 years. There's other examples like this. The cold fusion, the anomalous heat effect, first discovered in 1926. Just think about how different the world would have been. You actually have to sit back and think for a moment and contemplate the difference it would mean to have energy which you don't have to, which is infinite, clean, safe, and you don't have to pay for it. Well, it takes a while for that to be processed in your head, but I mean, imagine you could buy something that is just a foot square box, costs £80, you put it in your house, it runs all the electricity you need in that house, safely, cleanly, and infinitely. It's a simple device, has no moving parts, so it's very low maintenance, doesn't need to be fixed very often, if at all. No more energy bills, no more electricity bills, no more worrying about whether your double glazing has leaks. No need for this tragic thing you've seen, which actually is the fact that some old people who can't afford their heating bills suffer from the cold. They end up dying of hypothermia in winter because they can't afford the heating bill. This is incidentally what inspired Gary McKinnon, the hacker, to do what he did. He was concerned about these old people who died. If with anti-gravity, imagine if with George Pigot's balls that be levitated, you could levitate anything. You could levitate your house. You could have a house which you could move if you don't like where it is. You could move it. You could rise up in the air, move somewhere else. You'd be completely free to do what you wanted. It's not called free energy for nothing. It's not just it doesn't cost anything. And of course, you wouldn't. This anti-gravity, it's using Pigot's system wouldn't be expensive because it's energy that's released from the 0 point. Now, the conflict with scientists is that the technical term for these kind of devices is over unity, which means that they are more than 100% efficient. Now, this is where a lot of scientists, not evil people, not nasty, controlling people, not Club of Rome members, just any scientist, any physicist won't like that because it breaches one of the most fundamental laws of physics as we know it, and that is the law of conservation of energy. And that is there's a finite amount of energy in the universe, and it moves in a process called entropy from a high state to a low state, and you can't go backwards on the route of entropy and conservation of energy. You can only go in one direction. You can't basically, what it means is, in practical terms, is any kind of machine, any kind of system, you can't get more out than you put in. And you can't get a bigger energy output than input. Now, it would end, like I said, if you don't have to pay for the energy, it would end poverty in this country. It would end poverty around the world, though. It would end poverty in the third world. It would end famine and drought. All we need to worry about if it doesn't rain for a while. It's not the end of the world because you can get all the water you wanted from almost infinite supply to sea. Of course, you can't drink seawater, but then you have to desalinate it. It's a very simple process to turn seawater into fresh drinking water, or water to irrigate farmland. The problem is it costs money and it takes energy to do it. With free energy, it would be absolutely no problem. You could desalinate as much seawater as you wanted. Also, with free energy and anti-gravity, you could move it. You could almost fly it where you wanted it. In the middle of the Sahara Desert, you could have a farm. And that water could get there for no money at all. I mean, also,